Okay, so good evening, everyone. We should be live by now, I think. So I would like to say welcome to the next meeting, the Way Forward meetup. My name is Magdalena Konczkowska and I am Power Platform developer. And today we have a special guest, Damian Widera. Hello, Damian.
Hello, good afternoon, good evening.
But before I introduce you, Daman, and give you a stage for your fantastic presentation, just let me say a few words about us and where we came from, and we will move on your presentation then. So the way forward, the TWF community provides a platform for software professionals to discover and explore new trends in the technology field, learn from one another, get inspired, and have fun with fellow professionals. Give me a moment. I have to change the slide, I think. Yes. And if you wanna, of course, if you wanna find us, you can come and see our website TWF community, and see all of the links to our social, like Facebook, YouTube, and Meetup. And if you want to share your knowledge or tell something from technological area, you just fill the survey, and we will reach out to you with a proposal of arrange a meeting. And of course, moving forward, on the YouTube channel, you can see all of our previous meetups and recordings. So feel free to be inspired and watch what we got there. And for now, I think from organizational things, that last one I wanted to raise is after the presentation, please fill our survey to let us know about your impressions after watching this episode. We will be grateful for your feedback and for yourself. You can win a prize sponsored by Evenet Poland, which is a chance to get Udemy courses after filling survey. So thank you in advance. And now from my side, that I think it's it. And I would like to give the floor to Damian, who is Microsoft MVP and will tell us about Azure Synapse Analytics and in a business scenario. He will show us its fantastic possibilities for performing ADA and show real data and do the demo of EDA Spark. And for me, it's very interesting because in last year, I was impressed by the possibilities that were presented in the field of data mart. And I am wondering if the ADA has maybe a similar one. So, Damian, I will leave you alone. Stage is yours and go ahead.
Thank you very much. So let's start. Today's talk will be about data exploration in Azure Synapse Analytics. And the purpose of the talk is to show you how to approach to this kind of, let's say, problem or task you might have, and why this phase of data exploration, exploratory data analysis, is a very important task before you jump into the analytical part. So before you really start building the data marts, or before you really start building the maybe machine learning solution or some other kind of solution, you need to spend some time on data exploration. And I will show you all the examples in Azure Synapse Analytics. And first of all, I would like to tell you about the agenda. So the agenda is very simple: to show you a bit about Synapse Analytics and why we really need it, why this cloud service is needed, what kind of problems it can solve. And then I jump into data exploration. So I have prepared this presentation. It has like several slides. And then for each of the slides and each of the cases that I will tell you about, there is also a demo included. So probably will not be able to go through all the demos, but I will send you the spreadsheet, the notebook, sorry, and you will be able to play with it on your own. So you know the case and the importance of data analytics is growing, I would say, on daily basis. And from from my perspective and my experience, I see that day by day there are projects coming and people start asking what kind of analytics you can deliver and what kind of advanced analytics you can do, including machine learning, including some kind of predictive analytics. And to be able to do so, first you need to perform some work on data. And if you take a look into the slides I have, let me go back one more time. And I even try to, I try to have some pen here. So first of all, we need to start with business understanding of our data. So what kind of data we have, what, let's say, what answers we try to answer having the data. So in the meaning that maybe we can create a very good report, and the report should answer some business questions, some important question. Now we expect that the report is not some kind of static thing. It's not even a report you can show in Power BI, which is very interactive. But also in Power BI, you can have also the ability to have a report which helps you in the decision-making process. So the report, the Power BI platform can use its abilities, for example, to perform some kind of machine learning operations, let's call it this way, to scan your data set and give you some answer. But to make sure that you have important information and clean data, you need to prepare it. So then you have technical tasks like data understanding, data preparation. Then you try to have a model and information about, let's evaluate how good the model is and deploy the model. And of course, as the data is changing over time, so the model you have created could also at some point be not that accurate. So for example, your prediction or your analytics is no longer a good quality. So you need to start the process again and again. And I would say that after deployment, if everything is fine and the data changes over time, you will go back to this process here. So assuming you know the business information, you know the data, then you spend some time here. And this is where we come. And if I could say something, this is 80% of your time as a data engineer or data specialist. So 80% of your time you spend on this task. Once you have this one done, you can very easily do modeling, or you can more easily do modeling and perform evaluation and so on. So it's very important that you understand that the task has to be done, and that you have a good platform that helps you in performing this task. And here is the moment where Azure Synapse Analytics comes into the light. And you know, I should start the story, and it could be a very long story, but I try to keep it very short. But you know, this is how the classic data warehouse looks like, because the story and the analytics starts in data warehouse. So I use this example as data warehouse because I see how beautifully those bottles are placed on the shelf. So I can see that there is a place for each individual bottle. So the bottles are beautifully placed on their position. So I can imagine that, for example, this bottle is like, for example, one dimension. The second bottle is some other dimension. And here in the bottom, we have fact tables, which are also represented as bottles. And the picture is so beautiful. But then you can try to ask a question. What is the effort? Development effort, maintenance, administrative, whatever we have to do to keep our data warehouse in this shape. And how quickly can I introduce a change to it? So I would like to add a new bottle here. So do I have a space in my data warehouse? What does it mean that I put a new bottle on the shelf? What else should I do? And it occurs that it happens that this operation in classic data warehouse is not that easy, because we try to be agile, because our data changes very rapidly. And of course, what you probably know very well, also the business needs and business changes very rapidly. So having a good classic data warehouse most of the time right now is just not possible. There are, however, kind of summary here. It's not only about the logical part that you create some tables, views, and so on. It's also the storage part. Because if you build solution like this, usually on premises, you have to try to estimate how big my data warehouse is going to be in the next year. So you think, okay, right now my data load is like this. But if you would like to buy a hardware for your data warehouse and estimate how it's going to be in a year, in 3 years, in 5 years' time, so is it going to increase this way? And you buy a hardware that meets that criteria. And what if the next year your company start to grow and you will end up with trend like this? So your hardware will no more be performant. And there are a lot of questions like this. So having a classic data warehouse, especially on premises, right now is could be a very, very challenging task. That's why we try to go to the cloud as much as we can with the data and try to have all the benefits from the cloud services, because then we can very easily scale as needed. We can scale up, we can scale down according to what is really needed, how the data changes. By the way, if we think about data, we should also think that as of now, the data world is not so beautiful, like on the picture with the bottles. I would rather say it looks like this. So we are no longer thinking about, we still see bottles, right? But they are no beautifully placed. They are just thrown to some storage. The storage is called data lake. Here you see the data lake. And now the question is, I have enormous amount of data. Could be terabytes, could be petabytes, could be whatever size you think. And the question is, how quickly I can get data I need, process them, and deliver valuable information. And that's the challenge right now. So technically speaking, we really love data lakes because this is kind of unlimited storage, can take data in its native format. So it have a lot of benefits. However, swimming in this data lake to get the data you need can be challenging task. You can imagine how you would approach to this. Hence, we try to use, of course, the approach that Microsoft has to modern data warehouse architecture, in which we can just set up many different services to work together and build the modern architecture very quickly. And what's important, we don't have to have all those services. We can just pick maybe some of them and it still be working. So, for example, we can have any type of data, because the idea is it could be anything we want. If you have flat files, that's perfect. If you have Excel, good. Relational database, okay. If you need to connect to Twitter, Facebook, or LinkedIn, or some other third-party application, it's also fine. We can ingest, we can get everything, whatever data source you have, and store the data in the data lake, which I have mentioned. And then this is the decision point. What kind of services we'd like to pick? Because maybe we can perform everything in Azure Databricks and perform reporting directly from here. Or we can skip this step and we can say, oh, maybe in one of the projects, I don't need to have Databricks. I just can ingest data to Synapse Analytics directly from Data Lake. And I don't need this Databricks because I can perform the exploratory data analytics here. So this will be one possibility to do it here. And I can also do it here. And of course, there are other ways you can make it, because if you would like to have, you can also, for example, call Azure Function and perform the same type of analytics, data preparation, of course. Well, it could be more challenging task, but it's still doable. And then you can say, oh, do I need to have Azure analysis services? Maybe not. Maybe I can create this data mart, which we have mentioned, it's also possible. So Power BI data marts. So we have a lot of ways how we would like to approach the modern data warehouse architecture. I will show you Synapse Analytics today. And from the perspective of let's say the service, how it is built. So we have two different engines there. One engine is like a SQL. So you can say that it's like my old famous, very known well SQL server. And this is built in so-called dedicated SQL pool. So you can imagine it's like a distributed solution. So it's like a cluster with many, many nodes. I'm not going to go into details how it is built, but you can imagine there could be hundreds of them or even more in this solution, and you just say how big it should be in terms of scale. So you can quickly scale up, scale down as per your need. And this will be so-called dedicated SQL pool. Then you have so-called serverless pool, in which you can perform data preparation. You can perform all kind of exploratory data analysis as well. And here you will use some kind of T-SQL dialect. It's almost 100% SQL with some maybe small differences. But today I would like to show you something else. I would like to go into Spark and perform this data preparation task because, you know, the reason I'm showing Synapse Analytics is that you can, in one service, you can, in one hand, build SQL database and perform everything you want and build modern SQL database as a SQL part, or you can achieve the same using Spark. You have two types of engines, and you can combine them together. They are natively working very performantly. And so you can have benefits of using them both if you need to, but you can choose which one do you favor. So it will be also a matter of project decision, how your team is feeling. Do you have people who have worked with Spark, so they will choose Spark as their primary platform? Or maybe you have guys who know SQL best, so they will choose the SQL engine here. And of course, there is also a part of Azure Data Factory, which is called Synapse Pipeline. So it's like a part of ADF, of course, not the everything, but the part you need to perform the integration part. And of course, you have also so-called Synapse Studio, in which you can perform the development part, which I'm going to show you. And now let's jump directly into what is the topic today. So, you know, the exploratory data analysis, which I'm going to show you today, is like the puppy here. This is what I'm going to show you today. However, it's not like this in real life. In real life, you spend much more time to perform the analytics, the analysis, and create a good validated data set, which you can then use to perform other tasks. However, my session is here to show you the concept and what methods you can approach, how you can use the known methods to perform exploratory data analysis. So I'm going to show it to you on some very known data set. And so you will be able to reproduce all the steps that I'm going to do. However, in real life, you will have more problems. But if you use the methods I'm going to show you, probably you will succeed. And of course, there are not all of them. I try to gather as much as I can. So the next, slides will be just to show you how complex the exploratory data analysis is and data preparation is. And then we jump directly into the demo. So from now on, I'm starting to showing you slides with all the important tasks and the best practices you should follow. So this will be like my notes that I do, and I try to remember them. I just use this deck to on the daily basis, just to make sure that I follow best practices as well. So first of all, let's start simple. Let's start with selecting the data. So the idea is that if I have a very big data set, so if I ingested a different type of files, so when I open the file, it could have few columns like 10, 20, or it could have hundreds of columns. But the idea is for the analytics, you should choose only the subset of data you want. You should not pick all the columns from the file, just take what will be needed from the analytical part. So especially if you try to think about building machine learning models, you should try to narrow down the number of columns. You should limit the number of columns. However, you should try to gather as much data as you can. The more data you have, the usually is the better. So try to have as much data as you have. If you have millions of rows, that's fine. If you have billions of rows, that's even better, because then your model will be just more and more accurate. However, one of the case here, which I'm just having let's say the discussion about quality of data all over the day-to-day. So how do we ensure that we have a good data quality? How much can I trust the data source that I'm going to ingest to my project? Is it a public type of data? So we don't know who is managing it. Is the data trusted, or someone prepared kind of fake data and store it in the somewhere in the internet, and we try to make a reference to it? So you have to be extremely careful here, especially if you have your kind of organizational data, which comes from your company. But on the other hand, you need to also to enrich the model with some public kind of data to make sure that that you can build even more suitable solution. Then you have to be extremely care about the public data. You should make sure that you can trust them. And of course, you exclude whatever is not necessary. So it's like you performing the where filtering. So that's true that I told you the more data, the better. But let the data be important, right? If we don't need some kind of data, let's try to filter out them as quickly as possible. So that's the moment when we try to do the ingestion. We just take the data as is, and we load them to the data lake and try to perform data pre-processing. So that's the I already started to discuss it. So the part here is very important. So usually we think that we agreed the data format. After first ingestion, you know that it's not working anymore, because most of the time, if you use data which is generated outside your company or maybe in different departments, somehow it never comes in the agreed format, and you will need to perform operation. Could be some kind of smart ingestion, which I'm right now involved, how to make sure that I can have the data in the format I want. Then there is a problem. What about missing data? And we jump into this in a second. What are the options? What can you do? And of course, data sampling, which will be the where statement. And of course, when you do the development or you try to build the first draft of the solution, you don't need to load the entire data sets. You can only, for example, take like 1,000 rows just to make sure that you can push the data through the entire pipeline. So from the ingestion up to the Synapse Analytics, and make sure that you see how the data flows. Okay, one of the tasks which you will see quite frequently is what we do with nulls. So then the question is, the answers can be dependent on the situation. So one of the case is that if we see that something is null, we can drop the row. So if we have our data set like this, because as we ingest the data, we try to build something which is called a data frame. So it looks like a spreadsheet in Excel. So you have columns, imagine that we are doing something like this. So we have columns and we have data here, and some of the information here is not provided, so we have nulls. So then the question is, what should I do? One of the cases that let's remove the row, so we can just drop it. The other thing is that let's remove a column, the entire column. Maybe if we have a lot of nulls here, we should not trust the column anymore, so let's drop it. Maybe that's fine. Then we can say that we can have so-called filter cutoff. So we build a threshold. We have a threshold which says how many not null values should be in a row. So if, for example, if we have two nulls here, so by percentage, we can say if it's like 25% or 30%, we remove the row. However, there are other ways how you can deal with null data. And those are so-called imputers. So imagine we have a situation like we have a measures. We measured some physical information, could be like a blood pressure. So you have information, this blood pressure is fine, this one's fine. Here is the missing value, and here is also fine. And the question is, can we somehow deduct this value from the previous ones? And the question is, I have no idea. Sorry, the answer is I have no idea. I have to ask someone who knows this topic better than me. I am a guy who can do a lot of things with data, but not necessarily knows all the business details. So if you do some medical project, you have to have an expert. It could be a doctor who sits nearby you, and you can ask her or him, what should we do in that case? This is the data, and the answer could be remove the row. The answer could be, well, maybe we can take an average from the whatever is here. So maybe we can take an average value, and it's not going to change the meaning of the data significantly. Maybe we can perform median, maybe mean, maybe value which is most frequent. Maybe we have some constant value which we know it will be like a default one, or maybe we can take minimum or maximum. This is the strategy you can have, and it all depends, let's say, on the, you have to discuss it on the business layer, on the business level, not the technical level. So this should be a business decision, and you should be informed about it. And yeah, what else you can do? You can just do what is needed. However, when you perform this data analysis, most of the time we do it in Python. So we have a lot of support here for the operations that I'm right now telling you. The other problems that you will see quite frequently, it will be case, how are you going to treat the duplicates? Because you cannot leave them. So how to identify that you see a duplicate data, and how to identify them, and what to do. So usually we'd like to go this way, like delete a row. So you can imagine that you have a case like I have a key here. Like, for example, imagine that this is a key column. You have you have some values here, and you can say, oh, this is my so this is column key 1, this is column key 2, and you can say if a key is on this column, so the duplicate is here, and you have to remove it. But then there is a question. If we look at the row a little bit more carefully, we see that there is another column which says K2, and there are no longer duplicates. So if I could extend the key a little bit more, and the key instead of one column could be on 2 columns, that I don't have duplicates. So if you see a situation like this, before you really delete something or drop something, try to also review the part when I was talking about data understanding. The process is business understanding, data understanding, performing, data preprocessing. So go back to the data understanding process and try to find out whether you should keep the data or not. If you should delete, then the question is which one, right? Which one? Because they differ on some, the data differ on some other, in some other places. So It could be that you just select one of those two and you delete. And of course, you also analyze the data from the perspective of column, and you can also detect duplicates and try to remove the entire rows in that case. Well, before you really remove something, then try to understand whether it is really and how whether it is really important to remove or to keep. If you are sure that something is duplicated, you have to remove it. And now the case about outlier detection. I try to speed up a little bit this presentation, but to show you a demo. But you know, the outliers are extremely important in your data because you can have a question if those I have data like this, and I do something, some kind of prediction. So if I say, and what about this data point? Is it an outlier? So it's just not matching the pattern, or some other point is an outlier? And sometimes the answer is not that obvious. I would even say that this one might not be an outlier. It all depends on the context. So think about some kind of natural outliers. We all know Bill Gates, and we know that Bill Gates is kind of rich guy. He owns a lot of money. Of course, we know that he does a lot for charity, but still has a lot of money. So if you compare his money to my money, he is an outlier. From my perspective, he is an outlier. From his perspective, I am an outlier. So we just cannot compare together in terms of the money we have. So this is kind of natural outlier. However, if we also take a look into the errors that you can have, imagine that you measure a heart rate and out of the sudden you see something like this. So you know it's not possible someone can have this heart rate, a beat rate, heart beat rate, because the person would be dead after 1 second. So probably it's like a kind of technical error and the data should be like this. And the question is, what should I do with it? Should I treat it as null and maybe replace the value with something, or just delete the row? I don't know. So you should make sure that you can take the data and do something with them. You should definitely not keep them because they have a lot of influence on your data in the future, especially on the analytical part. So how to remove them? There is a way which is called 2K interquartile range, and this approach tries to remove the extreme values in your data. So I will show you, that's the algorithm, how it works, but I will show you this in the screen here. So the idea is that your data, you can have a statistical representation of your data. You see that this is a median value. You also see the quartile, so the third quartile, the first quartile. This is when so the first, here you should have 25% of your data. Up to the second quartile, which is a median, you should have 50%, and so on. To the third quartile, you have 75%, and that's it. But then you can perform some calculations, and you can calculate it this way. So the IQR, interquartile range, it's like a distance between the third and the first quartile. So the distance from here to here. So it's like a number. You see what is the value, and then you just apply a very simple rule. You know what is this value in your data, and then you take 1.5 times the IQR which you calculated. It gives you this value. So any point which is on the right on it, it's an outlier. Same story will be if you go to the left hand side. So you just remove all the extreme points. And yeah, sometimes this approach is also too extreme and it tries to remove too much data. And you can use some other methods, which is called kernel density estimation. It works that way that it estimates the probability density function for a given feature. So what is the probability there? So it tries to remove the outliers, however, in not that drastic way like IQR does. And of course, you should always try to find out if you have outliers in your data or not. So that's another approach and another method you should apply always to your data. Then the problem you may face, the next one, is actually so-called label encoding. So the label encoding means that you have values like a text, some kind of description, and machine learning algorithms, especially machine learning algorithms, they don't want to work on text data unless you do NLP, natural language processing. In other cases, text data is not something you would like to see. So in that cases, you'd rather change the text value into some numeric value, and because then you can have the numerical representation. However, be careful here, because in that case, remember that this number is derived from some kind of text. And I will give you an example. We all know the months in the calendar. So we have what is the first month? January, February, March, and so on. And we know that January is by convention is the first month, so it has number 1. February has number 2. But then my question is how we treat the numbers that represent months. Can I add 1 plus 2 and have 3? Does it mean that if I take January, add February, is it result to March? So this is a numerical value which is so-called not additive. So you cannot perform analytical operation on it. It's just for the convenience of the model you are creating. So this is one of the approach for so-called label encoding. The approach you may want to use in your data preprocessing is so-called one-hot encoding, and I will show you this by example because it's easier to understand. So imagine that you have one column that you ingested from the file, and those are just the rows, individual rows, and you see the data in your column. So you have like value red, yellow, green, and yellow. And then you try to have an approach which is called one-hot encoding. So one-hot encoding for each individual value. So like we have this one is individual, we have yellow here and here, and this is the green. So for each individual values, one-hot encoder creates a new column in the data set. And when you have this value present in your file, so this is information that my data was marked as red. This one was yellow because that's the third row, and it should be 1 as well here. It should be 0 here and here because that would represent this row. And we have green in the very last column here. Beautiful approach, but you know the number of columns can quickly explode. So you should be also very careful with this. And I think that, for example, the approach that I have with this months number would be fine. So you can encode like red is number 1, yellow is number 2, green is number 3, yellow is again number 2. So you are just like creating a dictionary of colors here. However, one-hot encoding is very widely used in data preparation. Hence, I'm showing it on the slide as an example. Now I just, we are just finishing I'm just showing you, just finishing the slides, and I'm going to jump into the demo pretty quickly. Transformations you do. You have to perform. There are a lot of transformation, and session about transformations could be like 2-3 hours long. What you can do with your data. But the examples that I have seen, which was very, very misleading, was that I'm measuring the same, let's say, physical value, whatever it is. Here I have a distance. So I have a measurement. Imagine that we are sitting in the room and the room is three-dimensional. And as usually, I'm sitting right now in three-dimensional room. So imagine that someone measured this length or this distance in millimeters. Someone measured the height in meters, and someone out of the sudden measured this distance in kilometers. So we have the same physical thing like the length. However, we measured it in different ways. So we have different scales. You see, we have different scales. And then it happens that some machine learning algorithms are very sensitive to the numbers also. So the scale is important because the machine learning algorithms can have a function of those inputs, and then can, for example, the model can be that the first input, which is in millimeters, could be, for example, a square of the nth number of x, and the y will be so multiplied by y or plus some kind of y function because it's small, so it will be y to the power of n, or so on. We don't know what the algorithm is going to do. However, it will be very sensitive to numbers. So the idea is to perform scaling. And in the slides, you will see how many scaling you can do. I will just tell you that you can do so-called min-max scaler, you can do standard scaler, and binarizer or normalization. And this will be done all for you automatically. And I will just tell you one of the scalars you probably will use all the time. It's so-called standard scaler. So the standard scaler looks like this. This is your statistical description. This is the statistical description of your data. It should be a normal distribution. Most processes in the Earth, unless you are quantum physicist, follow this pattern. So you can safely say that if your data distribution follows the normal distribution, then the standard scaling will be like this. Let's take the mean value, which is here, and let's move it to the point 0 here. And then we have our standard deviation. And let's make the standard deviation, let's move it here, but let's shorten the distance to have exactly 1 unit. In that case, exactly 1 unit, left and right. So in that case, you just need to perform some squeezing operation and moving the data set to the left-hand side, so removing the mean value. So your data will be, in that case will be standardized. And you will lose this problem. This problem will no longer be valid here because you will end up with the same scale of data. So it could be like from -3 to 5 or -1 to 1, but you will be operating on the same scale of data. So this will no longer be a problem with some kind of nonlinear approach. Then you can do data decomposition. Like, for example, if you have date time, you can split the column into day and time separately if you need it. Or you can perform something the opposite. You can perform aggregation. So if you have information, if you have 3 type of data in your data set, like you have length, you have width. Sorry, this is length, this is width. And someone also calculated the area of the rectangle here. So then the question is, maybe I can remove those information. Maybe those are no longer needed, and I can only keep area because I know the relationship between them. And maybe area is just enough for my model. I don't need to have the individual components of it. But I don't know. This is something you have to go through it. And so in the slides, you will see the different approach to perform scaling and other tasks. And I would like to quickly go to the very last slide because the time is passing and I still would like to perform some demo for you. So that's the last thing you always have to consider, so-called principal component analysis. So, imagine that you have a data set, and in the data set, you have like 12 columns, 12 features and you would like to predict the label. So you have feature 1, feature 2, and you have the last feature, or we can even call it feature, the nth feature of your data set. And here is the label. This is something you try to predict. So then, technically speaking, from mathematical point of view, you are here in so-called n-dimensional space. So we are living in 3-dimensional space, and we can imagine that, yeah, I can do some kind of fancy graphs, and I can imagine how 3-dimensional graph of information looks like. It will be like a cube, and you have points inside the cube, or you can even have a 3-dimensional function there. However, if I tell you, okay, let's imagine that n is equal to 12, are you sure you can imagine how it looks like? 12-dimensional space, what it is, how to imagine different relationship here. So the idea of the PCA is to reduce the dimensionality, usually to 2 or 3 dimensions. So if you have 2 dimensions, thing is simple. This is my reduced dimensionality, and I can draw the function, and I can imagine it. I see its properties, so I can understand the model, which is a great thing. But you cannot just take 12 dimensions and squeeze them to 2, because anytime you taking out one of the dimensions, you are introducing an error. So just changing the dimensionality from the higher dimension to lower dimension set, it introduces error to your data set. And then the case is how we can make it to make sure that we still have a good and very accurate model and still reducing the dimensionality. That's the case of PCA, and that's the last demo I have in my data set. And I'm just turning off the PowerPoint and showing you the Synapse Analytics. But I tell you more. Sometimes we are not reducing the dimensionality. Sometimes the performant action is to introduce a new dimension. That could be very performant operation. Okay, let's jump into right now into Synapse. I already created Synapse workspace, and what I have here is I can create. Take a look. I can create this very well-known SQL, so-called SQL pool. So it's like a SQL database. I have by default so-called built-in serverless SQL pool in which I can perform the exploratory analysis, but I have also created Apache Spark pool. So the Apache Spark pool, when you are creating it, you can then decide how big the pool is. So how many nodes you have. So I can have up to 200 nodes, and the nodes can be pretty big. So imagine that you have 200 nodes, each of them is like this one. So you can perform a really big data analytics, right? You can do whatever you want there. Because I'm doing demo, so I'm using the smallest cluster possible. It will have 3 nodes. If the cluster is no longer possible, it's going to stop. So for Apache Spark, here you can define what is the pause setting. So after 90 minutes, the cluster is going to shut down. But usually you can just wait like 10 minutes, maybe 15, and stop the cluster because you don't want to pay too much. And this is where the cloud really gives you a lot of benefits, because you will be paying only for the time when your cluster is used. And of course, the setting which you see here, I can choose that I want to have from 3 to 150 nodes or so, and this should auto scale based on the demand. So if I need more power will be added automatically, if I want to, automatically to make sure that the processing will end quicker. Okay, let's now jump to the what is important. So let's do the demo. The demo I'm going to do in Synapse Studio. So I have opened it already. And the reason I have opened it is because I'm keeping my Spark cluster alive. I'd like to make sure that the cluster is still warm up, because otherwise we will wait up to 5 minutes, and we don't have that much time. So this is the Synapse Analytics Studio. In Synapse Analytics Studio, you can manage your cluster. So you can go and perform some management part. You can create a new connection to some services. You can also manage how big your cluster is and so on. You can perform monitoring. So you can monitor how your cluster behaves, you have errors and so on, and try to also solve the problems. You can perform integration. That's the part of Azure Data Factory, which is called Synapse Pipeline. So using this integration part, you can also create pipelines here and creating similar workflows or data flows like you do in the regular ADF. Not all is possible what you can do in ADF, but several things are possible. Of course, I can perform development. This is what I'd like to do. And as you see, I can create my SQL script. If you wonder how SQL script looks like, then it looks like a regular SQL script. So I can create a select, taking data directly from the data lake, loading in as a one batch. I can have also my notebooks, and one of the notebooks is waiting to be run in a second. And I can also create connections to my Power BI. So I have everything in one place. And of course, I have connections to my databases. So Lake database is the serverless database. Here I can have SQL databases that I created inside Synapse. So I can have them as well. But we do pre-processing in Spark. So, as usual, we have to start from importing necessary libraries. And for the sake of the presentation, I'm loading a data set which you can find very easily. It's natively in the Spark. It's called Boston because this data set allows me to predict what will be the price of the home if for a specific configuration. For this configuration, how much do you get for the home, or how much do you have to pay if you'd like to move to some specific area? A lot of companies in Poland uses similar approach like we have here. So, there are like 200 different lines of code, which you should do on your own. And I'm going to show you the results that I already have to make sure that it's just shown faster. It's the same notebook, but it already has the results. So I don't have to run it and wait for my cluster even a bit. So, once you load the data, so once I loaded the Boston data set, then I can take a look what are my keys in the data set. So this is how the data set is built. So including the description of it. So you can build a data set like this as well. And you see I have some description, like I have 500 rows. There are 13 attributes, which are both numerical and categorical. And this is the description. So this is the column name, and this is the description of it. This is something that we will have in the data set. Of course, this is data. You see the origin of the data, and that's good that we have something like this, because then you can take a look what kind of data they have. And this is actually University of California, and they have pretty good data sets, both for training. So if you'd like to go and train, practice, master your abilities in different type of data set and how to prepare them for further use, you can go there and you can just test on different data sets. They categorized it, so this data set have different categories. So depending what you'd like to do, what type of task you would like to do, most of the data is real data. Some of the data is fake. You can choose what you would like to play with. I have chosen the Boston data set. So once I load it, then I would like to see, just by my eyes how the data looks like. So I'm just taking a look into the data. But then I would like to know what is the shape. So what is the number of rows and number of columns? This is agreed with the description. And there is also a column in the data frame, in the data set, which is called target. So this is something we'd like to predict. So you can imagine this is like one row. It's like an input vector. It has 13 columns. And this is the number I'm trying to predict. Then I have another row, which this is the something I'd like to predict from the values from the second row here. And then we do quick look in our data. So instruction of head. So what are the columns? Of course, we'd like to perform info method. So it gives us information about the data types. We'd like to statistically describe the data set. This is the function I use pretty frequently, because then for each column I have, I know what is the count, what is the mean value, what is the standard deviation. And if you take a look into the first slide, especially, take a look. The first, it's about how many criminal offenses we have in the area you'd like to buy a house. Take a look. The mean value, it's like 3.6, but the standard deviation is 8.6. The 75% of data is very close to the mean value, and the maximum value is 88. So you see that the data is very much skewed to the right-hand side. So it is still normal, this data distribution, but it's very, very skewed into the right. I try to perform some counting, take a look what is the max value for all the columns, what is the unique set of data for each column. So I try to get as much information as I can for my data set. And then I try to visualize it. So including the matplotlib, pyplot, and Seaborn, which is drawing the pictures in a little bit better way. So I try to visualize as much as I can. From this picture, you can see anything. So this picture is just to show you that you can visualize what you want, but trying to see some good, some relationships could be tricky. So then you try to visualize only the part of the columns which is important. And so I found some relationship. So definitely I see a good relationship here between LSTAT and the price. So, maybe I can have a function like a price is a function of LSTAT, whatever this column is. Because you see, the bigger the LSTAT is, the lower the price. So if the LSTAT is low, the price is high. So maybe then we can say, the LSTAT means what is the lower status of the population. Okay, so the poorer the place is, the cheaper the house, right? You see that there is really a relationship between this. So that's the kind of data you do. Then you please follow the operations that I was showing about data transformation. It's a lot of transformations here. Like I was doing something the opposite than in the slide. So I was checking what is the max value, mean value, and the minimum value on one of the columns. This column NOx means what is the overall pollution, air pollution. And then I see that the mean value is 0.55. So I have created a function which will generate me categorical data. And I say that if the actual value of the NOx column is greater than the mean value, then I will say that it's above. And if not, I will say that it's below. And I'm just introducing a new column to my data set by applying a function. And I can perform operation like this. And you see a lot of transformation here. So I'm just leave it as it is, because in that case, you will follow, for example, how to handle missing values with some examples. I created data set for you, and there are 5 strategies what you can do with it. And you can play it on your, of course, on your own, how to detect duplicates and how to remove them. And I will show you things about outlier detection. So especially this two-key IQR, which is called interquartile range. So that's the function which actually has it implemented. So I'm just taking the first quartile, the third quartile. I'm just calculating the distance between them. So that's the IQR. Performing multiplication. So that's the left-hand side, the floor. That's the right-hand side, the ceiling. And then I'm trying to calculate what are the values which lies outside those values, and performing the operations here. So then you see the IQR really works pretty drastically because it tries to remove a lot of data. And then you have to, before you really remove the data from the data set, you should ask someone, is it really a good approach? Because as I say, IQR can be very radically acting on your data set. So you should always try the other way. Maybe you can try kernel density estimation. And then this is where Python comes, is very helpful, because from the sklearn preprocessing, you can take some methods, and also from stat models, you have this KDE, so this kernel density estimation function, which helps you to reduce the data sets to find the outliers. And take a look, this method is not longer removing values which are less than 16, and here in interquartile, in the two-key interquartile range, we just remove values which were greater than 9. So take a look, number 16. So this is something that that kernel density estimation says it's fine. For EQR, it says it's no longer fine. So we can remove, or we can keep the data depending on the methods you will take. The other type of analytics you have to do is try to find some relationship in the data. And there is a correlation function which tries to find out what is the correlation between all the data you have. However, having this information in a tabular format might not be that easy to interpret, because then you have to sit tight and find out the numbers. So what you should do instead, you should try to generate a heat map instead, which represents the same information, however, in more graphical and friendly way. And then the question is what I'm looking for. And you should make sure that you look for values which are close to 1 or minus 1. So you should always have 1 on the diagonal, because that means that the column cream is related to itself, right? Because this is what we have on the diagonal. But then, for example, take a look. A tax column is related in 91% to the RAD column. So if you have that kind of relationship, you should think about it like this. Maybe I can remove one of the columns, because there is another one which is in relation. So maybe I can remove it. And this is how you can also say that some of the columns are no longer important. Of course, the technical process of removal column is simple. However, you should always consult it with the business person or the expert, subject matter expert, who can also tell you whether it is right, whether you are right or wrong. Here is a smaller heat map, only of 4 columns, so you can see what are the relationships here. And by the way, take a look. We have the price column, which we'd like to predict, and we have the cream, so the number of offenses, criminal offenses done on this area. And take a look how we can interpret this number. So if the cream value is going up, the price is going down with this coefficient. So if you can imagine that if it were a function of one variable only, so the price was a function of cream, that this would be the one of the coefficients. So you could have this as one of the coefficient of the function. So this is how you can read the value from here. I was also mentioning about this label encoding. So you can imagine that you have, it was like a t-shirts. We all know what the information is here. So we can then create information. How we can then have a label encoder which can tell us. Let me check whether. Oh, I will not able to run it because my session is no longer attached. But maybe I can run it from here, from the processing part. I just have to take a look where we are. That's the PCA, which will be done in a second because we have to pretty quickly finish our talk. So take a look. I have created a data frame with my unique values. Then the question is if I can create an encoder. So it will be a label encoder. Can I encode my data set? So take a look. Now I introduce a new column, which will be taken from the encoder. So my data frame will look like this. So I will have, where it is, those are the sizes of the t-shirts, and those are the encoded values. So take a look at how simply you can approach it. Categorical values, and you change them into numerical values, and then you can have the numerical values included in your model. Here is also an approach how you can work with the categorical, a different approach how you can work with the categorical data. So for example, in that case, if you have values, categorical data, you can perform one-hot encoding. So for one-hot encoding, you can imagine you for each individual row, for each individual value here, distinct value, there will be a new column created in the data set. So in that case, hopefully I run it. Yes, you will see how your encoder, how your data frame looks like after the normalization. So you see we have more values here than it was initially. Initially, we have one row. Now we have one column. It was this way. It's transposed, but it should be transposed to the columns. We have more information. And here you can follow the question about the information, how to perform scaling and different types of scaling. The standard scaler, I already told you how it could looks like. Then there is a normalization. Binarizer is pretty good one because then you can say, if I have values, for example, from 0 to 10, I can say that 5.5 will be my cutoff. So whatever is less than this will have value 0. Whatever is greater will have value 1. You can decide what is the threshold in your data, and you have data analyzed. And now we have the last part, which I would like to show you why it is important. So you should definitely take a look into data engineering approach, which is called PCA, Principal Component Analysis. So let's take a look into our data set. I'm dividing the data set into two, actually. So the input will be every data apart from the price column. This is the prediction I want to have based on the column. So I have 13 columns. So you can imagine that I have 13 dimensions here, and this is something that I'd like to predict. It has a problem because I have somewhere in my earlier transformation, I created the date F. So I need to go here to the data, to the notebook, which already has the information. Okay. I have this information in my other notebook, so I can show you what's going on. Then what you do is you divide the data set you have into the test data set and training data set. So you have training part for X and training part for Y. So what I have for an input and output, and something for testing. And it says that 70% data goes to training and 30% of data goes to the test. Then I always perform scaling. Here, this is, from my perspective, this is a must. So I do it all the time. I have chosen standard scaler because I know that my data follows the standard data distribution. So I have my data which are scaled. Then I'm importing PCA, and I would like to have that my 12 dimension or 13 dimension will be reduced to 2. And then you see that those are the dimensions. So this is how it looks like previously. So 13 dimension, and now they are just represented as 2 dimension. What is important between the newly generated dimensions here, so the 0 and 1, they have to be exactly, there is a right angle between them. There is 90 degrees between them. So they are just formulate a normal regular plane, which we know from the basic, from the primary school. And the idea is that we then once we reduce the 13 dimension to 2, then we can find out the prediction which we can draw on the screen. However, the goal is a little bit different. Because remember that now we are no longer having our initial information from the initial data set. Now it's reduced to only 2 dimensions. So the idea is that I would like to use the PCA and reduce the number of dimensions, because then I can also say how much of the components of the PCA I should take to explain so-called variation. So to be able to explain all the errors, the 100% error, I would need to take all the 13 dimension to create my 2-dimensional space. But for example, if my task is, if my model should be like only 85% accurate, sometimes 30% is like a beautiful value, sometimes 95% is just not enough. But imagine that we would like to have 85% of the accuracy. So then you just need to take 5 columns from your initial 5 columns, and then you can transform them by PCA into 2-dimensional space. The question is which 5? And the answer is from here. You see that the most important column is cream. It influences the price the most. This is the second column, the third one, the fourth one, the fifth one. So if you take the 5 columns, you will explain 85% of the variance of the model. So you can just say that those are not important. But if you would like to have more accurate model, like 95%, you should take 1, 2, 3, 4, 5, 6, 7, 8 columns, 9 columns. Because if you have 9 columns, you explain almost 97% of the variations. So you have to take 9 columns. So this is the 5th column, 6, 7, 8, 9. So only those 3 columns can be removed from the data set. So you can keep those 9 and create the 2-dimensional space out of it. The good thing is that we don't have to think about the math which is behind it, because it could be a bit scary at the first glance. We just use the method that Python has for us, and the sklearn library and other libraries. And what we need to have at the end, we need to have a platform. And this is Synapse Analytics. So take a look. I know that we went through rushing here, but through the demo, but I hope you can also replay it on your own. The idea is that I can use Synapse to perform data preparations, and I will reuse it in a moment to create next part. Because if we jump to the first slide, if I can go to the first slide with you as a conclusion here, what we do here in the first part, so this part, so if I spend my time on data preparation and I will prepare the data correctly, then I can perform data modeling. And each of the steps you can perform, the entire circle you can perform in Synapse Analytics, including the business understanding. Because there are methods, there are ways how to perform business understanding of your data and data understanding and so on. So data discovery and data preparation, modeling, evaluation, and deployment. Everything can be done in Synapse Analytics. Well, that's it. I have just shown you, I would say, the introduction to the data preparation. I try to give you as much insights as I can in terms of the methods you should use. Of course, now you should take the slide deck, take the code, and just start test one by one what I was showing. And probably after a day, you will work through all the data set, and you will know more. But I guarantee most of the method you will be able to take as they are described and introduce them to your project and have make use of them to make sure that your data is in good shape and good quality. Yeah, that's it for today, I think. I could talk forever, but I know that we have time constraint, and we already passed the time a bit. Oh, we cannot hear you. You are on mute, Magda.
Okay, I am on. So, Damian, thank you very much. It was very interesting, and I am really enjoy it. But can you tell us about the environment where we can use it and where we can test it? Because you show us a lot and show us some code that you prepare for us, I think.
Yes.
So can you just tell our participants how to, I don't know, manage to install the demo environment and to use the playground, some kind of like this one, because
So
I can prepare for us this one. Yes.
So what I'm showing is that I have created Azure Synapse Analytics workspace. Sorry, I have to go to this one. So I have my test subscription. You can go to the Azure and take a free trial, which gives you some money, like $100 for 1 month, and you can create a resource group. And within the resource group, you can just create this Synapse Analytics. So if you type Synapse, then you see that I can create Synapse Analytics. And you can just create this service, Synapse Analytics, in the region nearby you. So as we are here in the West Europe, so you can just say that, oh, maybe not in Australia East, because then there is a distance from Europe to Australia. You will be waiting for the data to flowing back and forth, but you can choose the region which is nearby you. So the configuration here is very simple, and you just press next or review and create, and everything will be fine. Once you have it, then what you will see is so-called Synapse Workspace. So the Synapse Workspace will be delivered only with this SQL pool, this one. For the demo I was showing, you need to configure Apache Spark pool. So to do so, you just go to here, Apache Spark pool, and you try to configure it. So my opinion is that let's choose the smallest one we can. So let's take the small one. Memory optimized, I wouldn't choose hardware accelerated. Hardware accelerated would be for kind of, for example, image recognition tasks. Most of the data engineering tasks we do in memory optimize. You have to call it somehow, so it could be like Apache or Spark pool or whatever you call it, Spark 2. And then try to choose the number of nodes. And let's allow Spark to handle how many nodes do you have and how many executors to assign to particular task. Let's do it for let's have Spark to manage it by us, and that's it. You just need to say review and create. You see there are some permissions will be done automatically for us. So you just create this. You just create the pool. When it's created, just remember that this pool will not be started. It will be there waiting for you. And you will be not paying unless you run something. So to make sure that you can run something, you just go to Synapse Studio. You open it. And in Synapse Studio, what you can do is when it is loaded, what you can do is you can go to the develop part here. In the develop part, if you'd like to follow my instructions, you go to notebooks. And probably there will be information about how to import the notebook. So if I send you my file, you just go to import and you will find it. Oh, there is some, take a look, I have one here. Okay, let's cannot be imported. Oh, it has in unsupported format. So maybe I did something wrong with that's another notebook. It's not the one I'm going to send you. So probably I did something wrong with my notebook. Probably I wrote it by hand. That's why it has problems. But once you import it, you just open it. And once the notebook is opened, you are still not paying for anything. But here you have to attach the notebook to your pool. So you just have to find your pool on the list. So you see my pool, I have only one. It's a small one. And the pool is not started because by default, it has to be started by you. So in my case, I'm going to the first cell, which has data. And then I just press this button, which says run a cell. So take a look. If I type run a cell, it tries to connect to the active session. So it says fail to create session. And the reason behind this is that my subscription is too small. So now I tell you a hint. Because if you are using this free subscription, you might end up with error like this. So then you just go to the settings here. This is like, you see, this is a configuration. You press the configure session. And then what you need to do is you need to say that I would like to have only one executor here. Because otherwise you have just no resources on your subscription to run it in many executions. So you just take it as one, you apply, and you can rerun, and hopefully now everything will be fine. It's starting right now. You see it's starting. So if the cluster is not working, it can take up to 5 minutes. My cluster is because my cluster is running and it keep the previous session. I just do not have I just have no space to run another notebook.
Understand.
But that's how you should do it. And then you can just go cell by cell. You can execute it, and you will see the results. And this is how you follow the notebook. And what I've done is I try to, when I was creating the presentation, for example, about the label encoding, and so if you go to the presentation, there will be information about the label encoding or some other things. I'm trying just to take the presentation to this screen. So you'll see it with label encoding, one-hot encoding. Yeah. So in the code, you will see the same thing. So first I'm explaining the label encoding. It should be somewhere here. And also the one-hot encoding, which I was trying to show you. So you see this is the removing the outliers, and then we see this information about encoding. So we have label encoding, one hot encoder, exactly like we have here. So I was following my slides and created demo for it. So you can take one slide and you see the demo for it in the code. And this is how you should, I think, in my opinion, follow it and practice a lot. This is like day-by-day life if you do data engineering. I'm not saying every day, but if you need to performing data pre-processing, you need to take some of the methods which are here in the file and apply to your data set. This is what I think.
I saw that you take the business case like T-shirts or map hitting, and this is very useful to visualization the needs of business. Like we try to manage with data, but it's managing is just for using in the real life. So
yes,
it was great.
Some business examples are easy. And the demo, I was trying to do something which everyone can understand. In real life, we have different cases. In one case, everyone can understand So it still be like t-shirts, the sizes. And some of the examples are very, very tough when you need to have an expert with you. So some kind of subject matter expert, depending of the nature of the project. And this person will then explain you the details of the business.
Yeah.
Because, we don't know everything. I am a technical person. I know a lot about the business, but it comes with an experience, my experience. So like 20 years ago, I didn't know anything about the business. Now I know more things, but still there are things that I don't know. So each new project is like something new to learn, which I really love to do.
I noticed that you mentioned about the gaps in the records. So it's necessary to speak with person from data, from business, to know how to the end user want to manage with this kind of problems. So you can fill your records by aggregation, by medium, or all different mathematical functions, but in the end you have to speak with business. What do you want to get? So I
Yes,
don't
yes.
understand.
And what is the best strategy, right?
Yeah.
So maybe we could remove the data and it still be fine. Sometimes removal is not possible. So what should we introduce instead? The null
Yeah.
could be mean value, could be maximum, minimum. We have many different approaches, but the decision has to be made by someone who knows the business part uh, very well. Technically, we can make whatever we want, but someone has to say what to do. And also, you should be always curious why. So I always asking why we do it this way, because then it could be that if I start to asking the question, the business person also start to think about it, and maybe they will see that the previous knowledge they have is no longer that accurate. Maybe we should change it a bit. So I really like to work with business because I'm asking technical questions, but business people try to understand, of course, what are the implications, and this is how we learn together. So I try to learn as much as I can from business people, and they try to understand also my point of view. Maybe not on that detailed level, but why I'm asking the question, because I see the implications in data.
Yeah. And the steps that you show us how to use it and how to manage with this tool, it's very valuable, because we now can see how to, I don't know, just put the data, put our queries in there, and get this end of calculation. So that
Yep.
was great. I really
That
enjoyed.
was also my intention. I created this, frankly speaking, for myself. I created different data sets, simple
Yeah.
ones, which I can see. And then, for example, this one is particularly fine because do you see null values here? And it looks like the question marks are the null values. This is how one of the systems inform that I have unknown value. So then you replace it, and then you have to remove it or do something with it. And if you follow code from these steps, there are different approaches to deal with nulls and how you should make it, including the inputters that I was telling you. So you can also take the information from here, practice on your data as well, and choose the best strategy.
Emma, it was very, very practical and I'm presentation, and I'm really enjoy, and I could listen about this kind of stuff a lot, but our time is over.
Yes, I
And
know.
maybe we can meet with you some another time, and you can just show us some more, like we talk about before our meeting was
Yep.
started. Your presentation with your daughter will be very, I don't know, attractive for me. How you manage, how your different way of seeing the possibility to use different tools will be great. But for now, we have to end our meeting, and I would like to very thank you for this one and for all this knowledge that you are sharing with us. So Damien, thank you very much.
Thank you very much for having me here, and hopefully to see you again with some other great topics. I have some of them, so would like to see you.
Thank you very much, and thank you everyone.
Thank you. Have a great evening.
Bye.
Bye.